is so far away that it has yet to complete an orbit around the sun since the Ice Age. I don't want to get all cozy with it because it's not one of us. But the way to figure it out is you look at the rest of the stuff that's orbiting out there and you say, this is collecting over here when it should be over there. There must be some unseen force of gravity enabling that. And so you back calculate the equations and you say, there's got to be an object 10 times the mass of the Earth over there to make that happen. And so thus the announcement.
Pluto used to be one of the OG planets in our solar system until it got kicked down to dwarf status. But guess what? It's making a major comeback, and not in a good way. Top astrophysicists Neil deGrasse Tyson and Michio Kaku just dropped a wild bombshell. Pluto might be headed straight for Neptune. Yeah, for real. A possible deep space crash course is brewing, and the consequences could shake more than just the outer solar system. So how is this even possible? Well, Pluto has always been a weirdo in space. Unlike the smooth, round tracks other planets follow, Pluto's orbit is totally off script. It takes a jaw-dropping 248 years to make one full lap around the sun. Since its discovery back in 1930, it still hasn't even completed one full orbit. That's how slow and strange it is. But here's where things get dicey.
Pluto had it coming from the beginning. It was never really belong. Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet.
Pluto's path isn't just long. It's also tilted and stretched out like crazy. Its orbit leans 17 degrees compared to the rest of the planets, and it doesn't glide in a neat circle either. It's more like a cosmic slingshot. Because of this, for about 20 years during each orbit, Pluto actually swoops closer to the sun than Neptune, flipping the script on everything you thought you knew about planet positions. Now, scientists are saying Pluto's route is getting way too close for comfort. Neil deGrasse Tyson and Michio Kaku are sounding the alarm about a potential cosmic crash that could have ripple effects even back here on Earth. Is this just a rare space fluke, or is something way bigger going on out there? Buckle up, because this mystery is only getting deeper. So here's the big question. If Pluto's orbit crosses Neptune's, why haven't they ever smashed into each other? The answer lies in some next-level cosmic choreography. Ever since Pluto was discovered, astronomers have been scratching their heads over its wild, tilted path. Unlike most planets cruising close to the ecliptic plane, Pluto cuts across space at a steep angle with an oddly stretched-out orbit. And yep, its route actually crosses Neptune's. But here's the crazy part. It never collides. Why? Because of the invisible gravitational dance happening between Pluto, Neptune, and the Sun. Scientists call this kind of puzzle the three-body problem. It's all about figuring out how three massive objects tug on each other through gravity, and predicting their exact movements is no joke. It's like a high-stakes, never-ending chess game in space. Astrophysicists break this down using some fancy terms, like azimuthal libration, latitude libration, and something wild called the VZLK oscillation. These aren't just scientific buzzwords. They explain how Pluto manages to dodge disaster every single time. So what's really saving Pluto from a crash course with Neptune? Azimuthal libration. Sounds intense, right? It basically means that even when Pluto crosses Neptune's orbital path, the two are never actually close. They're always at least 90 degrees apart, like being on opposite sides of a cosmic racetrack. Total lifesaver, and there's more. Latitude libration adds another layer of safety. It's the up and down motion in Pluto's orbit, meaning when it comes near Neptune, Pluto's usually way above or below the main orbital plane. So even though their paths look like they intersect, they're not on the same level. Literally. Space ain't just chaos, it's controlled chaos with some mind-blowing balance. Now here's where things get even crazier. Let's talk about the VZLK oscillation. This mouthful of a term is named after three brainiacs, von Zippel, Leithoff, and Koi, who cracked open how cosmic bodies like Pluto, Neptune, and the Sun really move when they start tugging on each other with gravity. This gravitational back and forth might sound random, but the VZLK oscillation shows there's actually a secret rhythm behind all that chaos. In Pluto's case, this oscillation is the key to understanding why its orbit looks wild, but still runs smooth for millions of years. Even with all its twists and turns, this pattern helps keep Pluto locked into a weird but stable lane. It's like the universe set up invisible guardrails just for Pluto. And don't get it twisted, space isn't just peaceful harmony. In fact, Pluto's orbit is what scientists call chaotic. That means even the tiniest change in where it starts could throw everything off way down the line. But thanks to the VZLK effect, that chaos gets contained, like a wild animal in a cage. Back in the late 80s, scientists ran deep simulations and found that despite all this orbital madness, Pluto's path stays rock solid for the long haul. And it's not just Neptune keeping things in check. Big players like Jupiter and Saturn are also in on this gravitational group chat, each pulling Pluto in subtle ways that stop it from spinning out into space or smashing into another world. Still, the bond between Neptune and Pluto is special. For every 3 laps Neptune makes around the Sun, Pluto makes 2, a perfect cosmic ratio that locks them into sync. That tiny detail? It might just be what's saving the solar system from a serious shakeup. Jupiter ain't just the biggest planet. It's also a cosmic bodyguard. Its gravity plays a huge role in keeping Pluto's wild orbit from spinning out of control. And Saturn? Yeah, it throws in a little backup too. New simulations show that even just Jupiter's pull is powerful enough to keep Pluto on track for billions of years. That's right, these gas giants are working as a team, like space bouncers making sure Pluto doesn't crash the party. Without this behind-the-scenes force field, our solar system would be pure chaos. If planets didn't follow the rules of these invisible forces, bodies like Pluto could go rogue, slamming into other planets, or even getting flung out into deep space. One hit could trigger a cosmic domino effect that no one's ready for. And with all this talk about Pluto possibly colliding with Neptune, studying its orbit isn't just important, it's critical. It helps us understand how delicate and dynamic the entire solar system really is. Pluto might seem unstable, but somehow, through a mix of cosmic luck and precise gravitational tug-of-war, it holds a steady path. That balance is mind-blowing. It all comes down to orbital chaos, the idea that even the tiniest change in a planet's position or speed can totally shift where it'll be millions of years from now. Pluto's orbit is a textbook example. One small nudge in the beginning, boom, it ends up in a whole different corner of the solar system. That's why scientists are glued to their computers, running high-level simulations to crack Pluto's code. They plug in all that crazy math to mimic how Neptune, Jupiter, and Saturn tug on Pluto, and what they're finding is both shocking and impressive. Even in a chaotic system, Pluto's been playing it cool, for now. Astronomers love to mess with the details, and for good reason. Even the tiniest tweak in a simulation can totally change where Pluto ends up. Back in the late 80s, scientists discovered something wild. Even with stabilizers like azimuthal and latitude libration keeping Pluto in check, its orbit is still a bit of a space rebel. One small change in where it starts, or how fast it moves, and boom, its path can spiral into something completely different over time. But here's the twist. Even with all that unpredictability, Pluto still manages to hold its lane for billions of years. That's the paradox. Pure orbital chaos wrapped in long-term stability. It's like a roller coaster that never crashes, even though it's full of insane twists. The real challenge? Predicting what happens next. When it comes to wild orbits like Pluto's, even the best forecasts come with serious risks and question marks. These orbits are chaotic by nature, and that means long-term predictions can get messy real fast. Scientists use advanced numerical simulations to peek into the future, but those models are only as good as their starting points. One small error in input, one oversimplified equation, and suddenly, the ending looks completely different. That's the game when you're trying to predict chaos. It's like trying to guess where a leaf will land in a tornado. Still, this research is more than just a guessing game. By studying how Pluto reacts to the gravitational pull of giant planets like Neptune, Jupiter, and Saturn, scientists get a deeper look into how the whole solar system works. Pluto might be small, but the way it moves tells us big things about space dynamics. In the end, Pluto's orbit is a reminder that the universe isn't just vast. It's unpredictable, mysterious, and full of surprises we're still trying to figure out. This whole situation shows just how every planet, big or small, plays a part in holding the solar system together. The placement and pull of each one can shift the fate of others, like cosmic puppeteers tugging on invisible strings. But here's what has people buzzing. If all these forces are working overtime to keep Pluto and Neptune apart, why are top astrophysicists just now throwing up red flags about a possible collision? Enter Neil deGrasse Tyson, one of the most well-known voices in space science. He's not just an astrophysicist, he's the same guy who pushed for Pluto's infamous reclassification from planet to dwarf planet. But Tyson's take on Pluto goes way deeper than just changing labels. He sees it as part of a bigger story about how our knowledge of space is constantly evolving. Tyson argues that reclassifying Pluto wasn't a downgrade. It was an upgrade in understanding. As we discover more and more objects orbiting the Sun, the definition of what makes a planet had to change. And Pluto, with its bizarre orbit and strange behavior, just didn't fit the old mold anymore. But don't think for a second he's ignoring Pluto's comeback. Tyson's been vocal about how complex orbits like Pluto's reveal how much we still don't know about space. That mystery, it's exactly what keeps the public locked in. He believes space isn't just science, it's storytelling. And wild events like a possible Pluto-Neptune clash, they're perfect chances to get people curious and asking questions. To Tyson, the strange, unpredictable moves of Pluto aren't just chaos, they're clues. Clues that we've only scratched the surface of what's really out there. And the more we explore those oddities, the more we connect with the biggest mystery of all, the universe itself. Neil deGrasse Tyson isn't sounding the alarm alone. He's joined by other top scientists who are now openly warning the public. Pluto's orbit might not be as harmless as we once thought. After decades of research, Tyson believes the three-body problem could turn from theory into real danger, and he's saying a collision between Pluto and Neptune might already be overdue. If that kind of impact ever happens, it won't just be a cosmic car crash. It could change everything. A Pluto-Neptune collision would be catastrophic. Because Pluto is smaller and made of mostly ice, it would likely get obliterated, sending a wave of debris flying across the solar system. That debris could pose serious threats to other planets, even Earth, depending on where it all ends up. And let's not forget Neptune. Even though it's massive, a direct hit like that could mess with its atmosphere or even shift its orbit slightly. And in space, even small shifts can cause major consequences. Now here's where things get even deeper. Theoretical physicist Michio Kaku has entered the chat. Known worldwide for his work in string theory, Kaku brings a whole new angle to this cosmic mystery. He sees Pluto's orbit not just as a weird curiosity, but as a key to the future of space exploration. Kaku believes that by understanding the complex gravitational dance between planets, especially wild ones like Pluto, we can start unlocking new paths for space travel. The lessons learned here could guide future missions to the edge of the solar system and beyond. From predicting hazards to planning routes through deep space, studying Pluto could end up being a blueprint for exploring distant, unknown worlds. For Kaku, Pluto's unpredictable moves aren't just about danger, they're about opportunity. It's a chance to link the laws of physics to the future of space travel. And in his eyes, every chaotic orbit is a puzzle waiting to be solved. Michio Kaku doesn't see Pluto's strange orbit as just random movement. He sees it as part of something much bigger. According to him, the gravitational dance between Pluto and Neptune isn't some isolated space oddity. It's tied directly to the deepest laws of physics. Kaku's life work in theoretical physics, especially in string theory, is all about breaking down these laws and figuring out how the universe really works at its most basic level. Just like Tyson, Kaku isn't downplaying this potential collision. In fact, he's connecting it directly to his theories. He believes that if Pluto and Neptune ever do crash, it wouldn't just be a rare space disaster. It would be a once-in-a-lifetime moment to test string theory in real time. Now here's where it gets insane. String theory says that instead of tiny, point-like particles making up everything in the universe, everything's built from vibrating strings. And in extreme situations, like a high-energy cosmic collision, those hidden strings might finally show their face. If Pluto and Neptune collided, the energy released could be off the charts, creating intense conditions that could reveal how particles and forces behave when pushed to their limits. This is exactly the kind of chaos that string theory thrives in. But there's more. Such a collision could also send out powerful gravitational waves through space. These waves could carry unique patterns or signatures that either support or totally challenge what string theory predicts about space, time, and gravity. For scientists, this kind of data would be gold. Now don't worry, Earth is far enough away that we wouldn't get hit by any of it. But the science that could come from watching something like this unfold, absolutely game-changing. Kaku says these are the moments that bring us closer to understanding the true nature of the universe, and Pluto might just be the key. Pluto's orbit isn't just strange. It's a perfect example of how space can be both orderly and chaotic at the same time. The way it weaves through the solar system, constantly tugged by the gravitational pull of Neptune and other giants, shows just how complex space really is. It's like a cosmic tightrope walk, and Pluto's been balancing on that line for billions of years. But don't think Pluto's the only mystery out there. The three-body problem is just one of many cosmic riddles we haven't fully cracked. In fact, scientists believe there are tons of other potential disasters waiting to unfold in space, and some of them could be even wilder than a Pluto-Neptune smash. Planetary collisions are super rare, but not impossible. There are star systems out there with planets packed so close together they're practically shoulder to shoulder. One famous example? The TRAPPIST-1 system, a wild neighborhood with 7 Earth-sized planets orbiting a tiny star. Sounds cozy, right? But it's risky too. In these crowded setups, planets pull on each other constantly, creating a kind of cosmic rhythm called orbital resonance. At first, it keeps everything in sync. But over time, that same rhythm can shake things loose. Paths can shift, stability fades, and if things go sideways, boom, potential planet crashes. Now, don't panic. Even in TRAPPIST-1, everything's chill for now, but scientists are keeping a close eye, studying these systems to understand how planets push and pull each other in tight spaces. Every new pattern they discover brings us closer to decoding how chaos spreads in the universe. And if that wasn't enough, there are rogue planets out there, loners drifting through space with no star to call home. These rebels used to be part of full star systems, but got booted out, either by chaotic gravitational fights or close encounters with passing stars. Now they're just floating, unpredictable, and totally untethered. Yeah, space doesn't play by simple rules, and Pluto's orbit is just the beginning. Rogue planets, those silent wanderers of space, can drift across the galaxy for millions, even billions of years. They're like cosmic nomads, kicked out of their original homes, now floating through the void with nothing to anchor them. And while space is huge and mostly empty, these lonely giants still carry a small chance of crashing into star systems they pass through. Yeah, the odds of a rogue planet slamming directly into another planet are tiny, but not zero. The vast distances between stars and planets act like space's natural defense system, making direct collisions extremely rare. Plus, rogue planets themselves are relatively uncommon compared to the number of stars out there. Still, if one ever did wander too close, it could cause serious trouble. Now scale that up. Imagine entire galaxies colliding. When two galaxies merge, it's not like a fiery explosion of stars smashing into each other. Instead, it's more like a gravitational brawl, where orbits get scrambled, systems get shredded, and planets can be flung out into deep space like pinballs. Some get ejected and become rogue worlds. Others spiral into chaos, crashing into stars, colliding with each other, or simply vanishing into the dark. But not all of it's destruction. Sometimes, chaos sparks creation. The intense gravity from colliding galaxies can compress gas and dust, lighting the fuse for brand new stars to be born. Space might tear itself apart, but it also rebuilds. Even our own solar system has seen its share of madness. Theories about the late heavy bombardment say that, about 4 billion years ago, something triggered a brutal storm of comets and asteroids. Giant impacts slammed into planets, including Earth, leaving scars we still see today. Scientists believe shifting gravity from the outer planets caused that wild period. It was a time when our solar system was a violent, unpredictable battleground. And just like that, Pluto's strange orbit? It's a small piece of a much, much bigger puzzle. The chaos of space doesn't always come from direct crashes. Sometimes it's the gravitational shakeups that cause the most damage. Scientists believe that during the early days of our solar system, the giant planets, like Jupiter and Saturn, started migrating. And when they moved, they didn't just shift gently, they disrupted everything around them. Their gravitational pull threw countless smaller objects from the Kuiper Belt and asteroid belt into wild, unstable paths. Many of these space rocks spiraled into the inner solar system and smacked straight into the terrestrial planets, including Earth. This violent chapter is known as the Late Heavy Bombardment, and it likely helped shape not just the surfaces of the planets, but their entire geological histories. But here's the wildest part. Those collisions may have even delivered water and organic materials to Earth. So the same chaos that once threatened the planet might have also helped spark life. And it doesn't stop there. As stars age, burn out, and lose mass, their gravitational hold weakens, and the orbits of their planets start to drift. This effect gets intense during late life stages like the red giant phase, or when a star sheds its outer layers into a planetary nebula. The result? Planets start to wander, sometimes crossing paths that were once stable for billions of years. Things get even messier in multi-star systems, where multiple stars are pulling in different directions. Their combined gravity can twist and tangle planetary orbits, creating conditions that are totally unpredictable. Planets can end up crashing into each other, getting flung out into deep space, or even getting snatched up by another star. But before you panic, let's be real. Even in all that cosmic madness, actual planet-on-planet collisions are still super rare. Space is just too big and planets are too small compared to those distances. But when disruptions happen, they do change the game, even if the collision never comes. Even though actual planet collisions are rare, the possibility of them happening keeps astronomers and astrophysicists watching the skies closely. Why? Because every scenario, even the wild ones, helps unlock the deeper secrets of how planetary systems evolve and how galaxies shift and grow over time. Pluto's orbit might seem like a small piece of the puzzle, but it's actually part of something much bigger, a never-ending quest to understand the true mechanics of the universe. As Neil deGrasse Tyson and Michio Kaku have shown, every orbit, every anomaly, every mystery takes us one step closer to decoding the cosmos. This journey isn't just about numbers or simulations, it's about challenging what we think we know and inspiring the next wave of thinkers, explorers, and stargazers. Because constant observation and discovery might be the key to predicting the next major event, even something as jaw-dropping as Pluto crashing into Neptune. So if this blew your mind, don't forget to like, subscribe, share, and drop a comment below. Do you think we'll ever see a planet collision in our lifetime? Let's hear your theories in the comments.